And while I'm waiting, I'm going to start to print. So I'm going to print the Triquetra, the new toolhead. I can show you the toolhead first. So it's this one. Those who have been following have been seeing this. I've been testing this toolhead with the new extruder, the Mjølnir Extruder, this guy. So this is a separate release, and it fits on the Triquetra Toolhead. So this toolhead will be available for, hello Maker Viking. It will also be available as for MJN, for Rails. I have a MJN version going here. It's not updated, but yeah, this is sort of how it's gonna look on the MJN. I'm not sure about placing the BL touch here, but it was just something I was looking into. It would be nice to have it hidden, but it gets very close to the hot end. Hello Andrew. Maybe not so smart to have it there. So that's why, you know, what we could do here is, of course, we could move the hot end further out from the axis, from the x-axis. But then again, we will have more overhang, and that's not a good thing. So, but this is an old version of the Triquetra, so let's have a look at the latest iteration. So first of all, this extruder, this Mjølnir Extruder, we can take a look. Hello Diego. The motor is NEMA 14. This guy. I can open the NEMA so we can have a look. Here's the NEMA. There should be a link down below to everything you need to build this extruder. So, and it's easy to print. Only 3 parts to print. And I have one. There's an assembly video coming tomorrow or Sunday. So subscribe for that one. Ymir. Yeah, Maker Viking. Use it on the Ymir, yeah. What kind of toolhead do you have today on the Ymir? Is it a direct drive or a Bowden? I don't know if you guys was watching me running the Mjølnir Extruder in Bowden mode. So I did a test in Bowden mode with this guy. And it's a small motor. It's only 12 Newton centimeter torque. But it did work actually quite good. We did achieve 20 cubic millimeter a second with the Dragon hot end. So the Dragon hot end I am running is the version 1 Dragon, this guy. And it is the standard flow, and it's, I think they rate it at like 40 cubic millimeter a second, but I don't know. That might be the version 2, or I'm not sure though. Anyways, we were able to push 20 cubic millimeter a second. And the last, my last test with the Mjølnir Extruder in on the Triquetra in direct drive mode, we did pull 30 cubic millimeter a second. So quite there's quite an increase running this extruder in direct drive rather than Bowden mode. Lucky is my dog is barking. I don't know why. Anyway, let's get down to business. So this is gonna be a release party, sort of, where we have I've released this now because it's been testing thoroughly, and I feel it's ready to be released. So beta files have been released for a while ago, and we're now in version 1, so we can take a look at that as well. Let me see what we have here. Yeah, so this is release 1 on GitHub. Should be a link down below to that one as well. Diego asked the weight of this. So the weight of this extruder, the extruder, just the extruder, is about 150 grams with motor and all hardware, nuts and bolts and gears and whatnot. 155 grams approximately. It depends on how dense you also print it, of course. I recommend like 2mm shell and about 20% infill should be good. Yeah. And also important when you print this extruder, because it's very sensitive in terms of tolerances. So for everything to fit, your printer need to be well calibrated, and these parts are designed for 0.5 millimeter line width. If you print them with like 0.45 or something, it will be a little bit strange. It will not fill up as good as it will with 0.5 line width. But if you run a 0.5 on 0.4 nozzle, you can still print 0.5 line width. I can show you how you do the reason for this just quickly. If we import, let's import this guy. Print part files, and let's do the front. The front is the biggest part, as you can see here. So 0.2 layer height is also what I recommend. It's designed for 0.2 layer height. At least you should have anything that adds up into millimeters. Like 0. You can use 0.25, but there are some fillets and whatnot. Might not be so good with 0.25 as with 0.2. You can of course use 0.1. And first layer is quite important because we have the logo. This should be printed without support. That's why I have these interface layers where we should have holes. It's because we can bridge. You see the red part here. So everything should print without support. It's designed for that. And many would say that this extruder is very similar to, oh, what's it called again? Let me see. The Annex, the Sherpa extruder. Many people are saying, oh, this is same as the Sherpa. The Sherpa is I think looks very good. It's not, this is something I designed myself from scratch. And we use the same gears. So we use the BMG gears for everything. I'm going to show you that later. But first of all, let me go through the slicing process of this. So I'm gonna set my line width to 0.4. Then we're gonna see what happens inside and why it would be. I hope I get some errors now. Let me just go back here because I had a lot of changes. So 0.4, slice, preview. Well, if we go inside here now, yeah, you will not see it so good actually on this part. Yeah, so that was a bad example. No, I don't think it is. Let's go a little bit further up. Of course, this should not be printed with a brim, so leave the brim out. Yeah. We should use 4 lines, at least 4 lines. You might actually be able to print this with 0.4 line width if you go 5 lines. There are some parts here which should not... Actually, I don't see a problem here now. Okay. Okay, so it actually works with 0.4 line. So that's not a problem now. It must be something else I've been working on. But anyway, I recommend 0.5 because then I'm sure that everything adds up. Diego, Orbital, are you asking someone else or me? Let's go to the extruder. Have a look at the CAD model. And let's explode it. Here you can see all the parts. So we have the front here. And we have the base. And then, of course, the motor, the latch. So what you need to print is the front, the base, and the latch. And everything prints just laying down, no support, and yeah, just import the parts into your slicer and it will... I already oriented the parts in the way they should print. And then we can see all the hardware. So we have the motor, link down below. We have the gear set. This is the BMG gear set. So we have this. We have the dual gears, 2 of those. If you already have a BMG, you can use those gears. And we have the bearings, the big gear, and we have the pinion, which sits on the motor. And then there are some hardware as well. I'm going to the repository. Let's have a look at the repository. We have in the document library, we have this drawing. So it should be easy to figure out what you need in terms of hardware, in terms of screws and nuts and bolts and whatnot. I don't have any links for that though. They are all M3s. So there are like 3 nuts and actually it's 4 nuts. 4 M3 nuts and some screws. I'm just going to take a look in the chat before we move on. Diego, are you asking about similar to another extruder? Well, people told me because I posted this during development. I posted it on a Facebook group and I was told that it's similar to the Sherpa. And I had a look at the Sherpa and yeah, it's kind of similar because we use the same hardware except the Sherpa is a more complex assembly than this one. So I wanted something simple, but I also wanted it to fit together with the Triquetra, so it's like a smooth fit. So you can't really see it, it looks like one part. We have the extruder here. So if you use the Triquetra Toolhead, then it would be nice to have the Mjølnir Extruder. But there are many extruders out there right now, many lightweight ones. There are the Orbiter, which uses a different gear set than this, and the Sherpa, and I think there are a few others as well. Anyway, I wanted to design my own, and I don't know if this is better or worse or whatever than anything else, but at least it's been tested, it works great, and that's why I release it. So can people use it or not? You can try it out if you have the gear set. Yeah, it's not much cost to print it. The filament cost will be like minimal. Yeah. Okay, so any more questions about this extruder? I don't know if you saw the test videos. If you subscribe to the channel, then go to the channel, the YouTube channel, and then you will see I have 2 test videos, one in board mode and one in direct drive mode. Hello, Luis. Yeah, what party? There's a big party going on. Release party for the Triquetra Toolhead and the Mjølnir Extruder. We can now, I think, go to the Triquetra. Here we have the extruder, and then we have the Triquetra. So this is beta, public beta release. I want to test this more. I just made a new change to it. I can show you what I did. Thank you, Daniel Lincoln. Yeah, he says that the Sherpa has a different ratio, and that's correct. And I actually ordered a motor for a different ratio myself, but I have not received the motor, so I'm not able to make a 5:1 version. But anyway, the 3:1 version also works fine, so I probably will also test the 5:1 gearing ratio and see if there are any differences. But what I recently made a change here to the fan shrouds, because the airflow was way too low. It did not cool enough it did not cool close enough to the hot end. So I did make some changes here. So now it's much closer, and I have not tested this. I'm gonna print it tonight. So we can actually do that now. I can start the print, so we can have a look at also how I slice it. Let's go to Triquetra. Triquetra beta print files. And we're gonna have this one. Why do I have 2? Okay, whatever. This one I want. Let me have a look one more time. I'm gonna have the latest one. Okay. So this is actually the previous one. I have to figure out. Let me delete this guy. That's it. So I need to update GitHub actually. I'm gonna do that right now. So now GitHub is updated. So there are only one Triquetra front. And I do have a profile for this here, and we're gonna go PETG 200 and 0.5 line width. We can do 0.4 line width on the first layer because there are some because of the logo and whatnot. I'm going to use 0.2 layer height and then 10 top layers, 10 bottom layers, 4 lines, and then 20% infill, 25% skin overlap, 230 on the nozzle for this PETG. Use whatever is suitable for your filament, and then 95% flow. For speed, we're not going to go very fast. I think I'm gonna go like 40 all over actually. Maybe outer wall we can do 30. I want this to be nice, and 20, only 20 on the first layer. So retraction is of course now like 0.5 or something, maybe let's say 1. I have not calibrated the retraction on the new extruder, so I don't know. And combing mode, I'm gonna nothing skin. Yeah, we need some support on this guy. I'm gonna show you how I'm gonna support this one. Fan speed, I'm using 60 for the PETG. We can do a skirt. Okay, that should be okay. I'm gonna have a look in the chat soon. First of all, let me show you how I use support blockers. I'm not sure everybody knows about support blockers, because I only want support. Actually, we don't need support here. You can bridge. Yeah. No, we can bridge this. Nope. No, there's one place we need support. I just figured out. Okay. So let's generate support, and we want it everywhere. And I want the support C distance to be 0.2. And then I'm gonna add some support blockers. So I'm just gonna click the part. I'm gonna go to support blockers in the left window here, the left of the window, and they're just gonna click on something red. There's one support blocker. I'm gonna click the support blocker. I'm gonna scale it non-uniform. So basically you want it like almost everywhere. Just make a big block first. Then move it a little bit. Doesn't matter if it's like too big. So I need to move it so it's like, because the part I want supported is like this, where the hot end mount is, the hot end groove, the groove for the hot end, I want supported. It's like the only thing I want supported. I'm gonna add another support blocker. I'm gonna scale that one. Just drag it out. It's not so important. Move it around a little bit. Look from the top and drag it down here. That should do it, I think. Yeah. So let's slice it and see if we have the support where we want it. Go to preview. Now we can see we have support under the groove mount. So that's also important. I want to talk about the groove mount, because this groove mount fits the V6 type hot ends, and I will make a carrier for more hot ends. I will, like this front, I will also make one for the NF Crazy and various others, so you can switch those out, so that's no problem. Okay, 3 hours 23 minutes. That's what's a little bit long, but actually I didn't want these supports here, but let's just leave them. Yeah. Okay, let's go. I can always up the speed a little bit. I can see something is going on there I don't like. Let me go a little bit down. Okay, so we can see here there are some gaps I don't like. So I'm gonna actually fine tune that with my line width. I'm gonna set wall lines to 0.499. That's something that actually fixes stuff like that. Yeah, that's what I want. Now we have a uniform wall all the way. That's great. I save some time as well. Okay, let's print this. Just gonna go to do it. I'm gonna come back to the chat and see what you guys are asking me. You see, we are already. I'm gonna pause this and cancel this print. I'm gonna upload it one more time. Okay, so let's have a look and see what you guys are talking about. Thank you, Daniel, for documentation. I didn't know that it was documented well, but it will be better, I promise. Diego asks if we can use a belted printed gear. I don't know. I'm sure it's possible somehow. I don't know. I'm not gonna do that. I'm not gonna design that myself. So I forgot to tell you, actually, I did publish the source file. Let's have a look at the source file. Here we go. Release, yeah. If we have a look here, in the code, and then go to source files, you will see you have a Fusion file, which you can download and you can play around with it, and you can modify it and do whatever. And Felix asked if it would be easier to use a support blocker to select where you want support. Well, that's kind of what I did. I know that in Prusa Slicer, the problem is that I'm not able to use Prusa Slicer. I don't get the results I want. I really want to use Prusa, but I'm not able to do it. In Prusa Slicer, I think you are able to put supports where you want them. There are some paint on supports or whatnot. I'm not so familiar with the Prusa Slicer. But I know Cura like my back pocket, so yeah, just do it like this. And the print just started, so we can have a look at how the first layer will go as well. Let me just find the camera. I have a camera running on my printer, so we can have a look at that as well. Seems like there are some lag here on the camera. Oh, my my C offset might be a little bit off. Yeah, I need to stop this and start it again. I'm not going to use time on that now. Anyway, I will figure that out. I just changed the filament, so something is wrong. But anyway, let's move over to the questions. Felix asked if I used parametric design. Yes, of course. I always use parametric design. I'm an engineer by trade, so I have a master's degree in engineering design. So using parametrics is something I always do. We can have a look at the Triquetra. If we go back to like here, you can see I've done some parametrics. I have not like gone into, we could of course use parameters like these. I've not done that. That's something I rarely do. I do it sometimes. It depends on what I'm designing. But, okay. More questions? If I tried Idea Maker, yes, I did a couple of times. It's a little bit strange for me to navigate in Idea Maker. So again, it's because I've been using Cura forever, so I know where everything is. And in Idea Maker, I don't find what I want, so I don't want to use time on looking around. So in Prusa, actually, I do find what I need to find, but I don't get the results I want. So that's then another issue. I use 4.8 on Cura, but I don't know what you're talking about, Diego. Okay, so I think I got all the questions answered so far. If I didn't, please ask again. And then we can move on to looking into the Triquetra and a little bit more about what's going on here. As I said in the beginning, there's a version for rails, but what you see on the screen now is for V slots, and it's particularly for the V baby, but it could be modified for various V slot printers, of course. It depends on where your belts go and so on. But this also have like a bracket for end stop over here, and a bracket for the BL touch over here, and then we have the 230-10 blower fans here. I use optical end stops. You can use mechanical end stops or whatnot, no problem. And I have like a part to route all the cable, the wires and whatnot down here. And this is meant to be a PCB. I've not been able to design this PCB yet, and I'm not sure where I want to put it. If you have any good ideas where to put a PCB here, so we can like connect our fans and everything onto this PCB and just have one connector going from the controller and down to this PCB. I'm looking for a D-sub, a 25-pin D-sub or something. We could use RJ45's Ethernet connectors, but then maybe we need 3 of those. Yeah. We might... maybe 2 is enough. I'm not sure. It depends on how much stuff we want on here. The BL Touch uses 5 wires, but we can actually do with 4 of them. And then there's 3 for the end stop. We could use some are using like sensorless homing. I'm not able to get that calibrated well on my coreXY. So that's why I still use an end stop, because then I know it stops where it should stop. Yeah. Martin asked if the Triquetra mount on a stock V-Baby. So yes, absolutely. I designed it for the V-Baby, and there will be more designs. So I will design also one like base model, which can be modified for like everything. There will be one for MJN rails. I am doing a MJN conversion for the V-Baby as well, and it will of course fit on other MJNs. We have the MJN version here, but it's not updated, so that's why this looks a little bit different. Yeah, and of course, if let's hide this guy. So we have a blower here, a 4010 blower. And what it does is actually it looks inside. Let's go to analysis and have a look at, we don't have the section. Let's inspect and see inside. And we can see the airflow going from the top, the fan. So they have the fan here, and it blows down here, and then it's routed through the cold end on the hot end, the cold end on the hot end. This part is called this black part is called it's called the cold end. Yeah. I hope you understand me. We can also have a look inside the layer fans, or the part cooling fans. So they work like this. And it's not, now I routed this layer fan more towards the nozzle because it was blowing too much on the side. So I'm gonna try this version and see how that works. But I'm not sure. I'm sure I forgot something. But you can always get in touch on Discord or on Facebook, of course, in the builders group, the Viking 3D builders group. Yeah. So and we can talk a little bit about future plans as well. So let me open. I'm working on something here. I'm designing a new printer as well. I'm not sure on what I want, so maybe you guys can help me out, because it's actually for the community, it's not just for me. But what is going on now is, like, I released one printer in 2017, and then I released one in 2019, and then I think it's time to release a new one. We already have the Viking version 2, but I've been playing around a little bit with a railed printer, using rails and also kinematic 3-point bed leveling, which would be very, very nice to have. And as you can see, I did mount the Triquetra here on a rail, and I have some rails under here, and it's just a very simple frame. It's a 2020 frame, and what I'm thinking is that this should be more sturdy if we open it up in the front. And this is also, I'm thinking, this should be enclosed, and maybe there should be metal parts. I don't know. I started working on some metal parts here, but I guess we will start off with a printed part version and then maybe move on to metal parts. The thing is that this is so similar to the BLV MGN cube. It's kind of too similar, so I don't like to design something that's so similar to something else. So I need to figure out another way to go. A cheap printer. Yes, maybe we could do like something like the Voron switchwire, but like in a simpler, because I kind of like the coreXZ, I think it's called, coreXZ, not coreXY, but coreXZ. It would be interesting. I have one more frame to show you. It's the race. So I started on this printer a while ago, actually. Also gonna have a look in the chat to see what you guys are talking about. Just gonna open this one first. Yeah, so this is a little bit beefier, but again, it's also quite similar to the BLV MGN cube. I'm not sure that's a bad thing, but I mean, there's only so different it could be, because it's a frame, aluminum, and it's square, and yeah, whatever. We could design a printer with a moving bed. Yeah. Just a simple, something very simple, but I tend to over-engineer as well. I don't like this bed setup I have here. Actually, I bought ball screws, but I'm not sure if we should go for ball screws on the Z-axis or belt-driven. Belt-driven does work well. And ball screws are never straight, even though they are straighter than lead screws. They are not straight if they don't, like the cheap ones are not straight. So if we are going to use ball screws, then we need some sort of wobble compensation system. Okay. Let me have a look. Breakout board from BQ, Mohammadroid. Do you have a link for that? XT60, I don't like the XT60, Louis. 13-pole DIN plug. I'm just gonna have a look in the chat because I missed some questions here now. I'm not sure what a 13-pole DIN plug is. Yeah, of course, we are now talking about this PCB. So I did actually start on a PCB here. I can try to show you guys. I started prototyping. This is not my strong suit, but I have like two RJ45s here, Ethernet connections, and then I have some not Molex, JST XH connectors here for fans, for motor, for heater, for thermistor, and for BL touch on here. So I'm working on that. I have designed something in ECEDA, but we will see how that goes. It would be nice to have on. So this is another connector, which is a DB. This is a DB15. I'm not sure if 15 pins is enough, so we have to figure that out. Don't see my screen. What the fuck? Thank you for saying that, Barry. I was totally on another page. Here you can see the screen. So I've been talking for a while now without you seeing my screen. That's totally, yeah. Okay. So this is the the 3-to-1 gearing belted gear I was talking about, which is over here. And to stop the bed from falling, if you're using this as a C drive, we could use a braked motor like this. But of course, it's more expensive. It's like twice the price of one stepper motor. Okay, sorry for not showing the screen the last 10 minutes or whatnot. I'm not sure when I moved, but I think I covered most of what we should cover today, and it's been nice having you guys around. So, and again, please go to Facebook or Discord and keep on discussing, and we can do another live stream when I have more stuff to present. So anyway, now we have released what we should release. It's been a great release party. Let me go back to the releases. So yeah, the beta release on the Toolhead. I hope some will test it. And the Mjølnir Extruder with a source file for those who want to modify it. Okay. Any more questions before we sign off? We've been on for 1 hour now. If not, I will just say have a good weekend to everyone, and happy melting and making and whatnot. And I guess I just see you guys soon.